In this session, we want to look at implementing a non-constructor method from our UML into PowerShell. So we start with our class named Stuff that has 5 members. 3 of them are properties and 2 of them are methods. Of the methods, one of them is the constructor and the other is a plain old method. The difference being that the constructor method never has a return type because our code doesn't call it directly. The system will call it whenever an object is newed up. So it doesn't have a place to return something to us. It can't return something to us because we don't call it directly. The double stuff method, on the other hand, will have a return type even if it's to say nothing. And so then we see that in the constructor, we're newing up the properties with initial values as we did last time. And now in the double stuff definition, method definition, I am taking and saying that property C should be the value of property C multiplied by 2. Okay. And again, this is our assignment operator. It is not equals because the assignment says do what is on the right-hand side first, evaluate it to a single value that can then be assigned to the left-hand side. So this is going to say, hey, whatever the current object's property C value is coming into this statement, multiply that by 2, and then assign that to property C. So on the right-hand side, the value of property C will be what it was before this statement, and on the left-hand side, property C will be the value after the statement. Okay. Additionally in the model then, after we new up a couple of things, we will call thing 2's double stuff method. To have it do its thing, it comes back, returns, and then our program ends. Okay, so let's look at the code over here. We can see that here is the constructor method, and now here is double stuff. And we're saying this member property C is assigned this member property C multiplied by 2. We use asterisk because an X would be confusing with a letter X. So we use the asterisk as the multiplication operator. Let's see. And then finally down here, we're saying that thing 2, member double stuff. And notice that's the entire statement. So there's no parentheses. There's no statement terminators or anything after it. Wouldn't be in PowerShell. Could be. But anyhow. And most of all, there's no curly braces, so there's no definition. So if we're not declaring or defining double stuff, then we are calling it. We're invoking it. We're saying, do it. So this is going to cause double stuff to occur, which means it's going to come up here in the code, wherever this happens to be in memory, execute this statement, and then return back to here. Return to the next statement, which there is none, so it ends. Okay, so let me select that, copy that. Bring that over, paste that in my editor. I'll just save it as is and then come over to PowerShell and say, hey, PowerShell, take a look. And PowerShell says, yep, I'm good with that. I'm happy. It ran it. All that stuff happened. Memory was allocated. The 2 objects were instantiated, and one of the double stuff method was called. Okay. Otherwise, we would have gotten an error. So we're like, okay, well, if that's the case, let me prove that. So I'm going to say, before I call the double stuff method, I'm going to say, hey, let's take a look at, let's see, $ thing 2, member property C. Okay, so this should be whatever it was initialized to. And then I'm going to copy and paste that same thing after the call to double stuff. And then I'll run that. And we see that sure enough, the first time we called it, we wrote it was property C, that was right after the constructor had been run. And it was newed up with a value of 42. Then we called double stuff. So it came up here and said, oh, take the value of property C, whatever it was before this, which is a 42, multiply it by 2, and assign that to the new value of property C. Overwrite the 42 with 84. And so then when we came on and said, hey, write that out to the host, it displayed the 84. There you go. We've created our first method. We'll add some parameters and some return values in future sessions, but play with this. One thing I'm thinking is that what I haven't set up to this point, you may have discovered that, is that the spaces are not critical. In fact, remember a moment ago I mentioned offhand, I was thinking other languages and things, and I said, we said double stuff, parentheses, and then there was no statement terminator here, or curly braces. What did I mean by statement terminator? Well, PowerShell being interpreted is line oriented. Okay? So when we put statements on individual lines, that's all we need to do. Now it does turn out that there is a statement terminator character. It's a semicolon, like in a lot of C-based languages. So if we were in Java or C or C++, we'd have to be terminating all of these statements with semicolons, because those are compiled languages that are not line oriented. Okay, so first thing I'll do is I'll prove that, hey, if I throw that semicolon in there and I come over here and I say, hey, run the program, it runs just like before. Now I know what you're thinking. You think, oh, well, that's because you can put any character in there you want. Like, let's say I put a colon in there. Okay, so I save that, I come over here and I run this, and I get an error message. So there's my proof. It didn't like the colon, but for some reason it was okay with a semicolon, and I'm suggesting that that says this is the end of the statement, whether it's the end of the line or not. Because what that means then is if that's the end of the statement, whether or not it's the end of the line, I should be able to put this next statement right after it on the same physical line in my source code, but they are two separate lines, two separate statements in PowerShell when they get interpreted. And so sure enough, it still runs. The other thing, while I've got a couple minutes and we're talking about formatting and things like this, so all of this program could be on one entire line. Okay, I could take all those spaces out, and wherever the line ends, just throw a semicolon in. Okay. It becomes more of a style thing, and what you determine is readable, but not a problem. The other thing is then that spaces, you'll notice I've been indenting here. That is not critical. So I could say, okay, let me get rid of all of these spaces. Oops, didn't mean to get rid of that. Curly brace, I just wanted to hit delete in that backspace. There we go. Okay, that's enough to prove the point, I think. And we can see that, yep, it still runs. So the translator does not care about white space. Extra spaces, tabs, they're there for readability. Now, occasionally you will find a language like a Python that uses indentation for a specific purpose, for blocks instead of like curly braces. But a lot of C-based languages do not care about white space. Again, it becomes more of a readability thing. It becomes more of a style thing. I will never dictate style to anyone, but I will suggest what I think is better or not. For example, I will tend to put spaces around my operators. Okay? You don't have to. The operator is a special symbol. So when the translator comes in here and is looking at this character by character, when it sees that equal sign, it says, oh, that's an operator. That's an assignment operator. Clearly, that must be separating whatever was on the left from whatever was on the right. And so, sure enough, still works fine. But I will argue that if we condense it all down, then it makes it less readable. And again, you could put this entire program on one line with very few spaces in it. In fact, like I can get rid of that space because that's a placeholder. The parentheses are an operator. They're special characters. The curly brace is an operator. That's a special character. I'll throw that up there. Boom. And yep, all still works, but you can see it's getting much less readable. And I can't stress enough, this code that you and I are writing, the machine, being the processor, never sees it. So it doesn't matter what it looks like to the machine. The translator is going to take this and replace it with some machine code. So since it doesn't really matter to the machine, we should make it as readable for humans as possible. And that includes you and I, as well as other people who may be looking at this code. So keep in mind that you might write this code today and not have to touch it for 6 months. When you come back, you want to be able to read it easily. Or you'll be looking at somebody else's code that somebody else wrote, and you're trying to read it. That's my piece on that is readability is key. I do not mind typing a few extra characters to make it more readable.